Well, hello everybody. Thank you for coming. Welcome to Chapman Construction and our fourth CMP presentation. We are delighted to have you here today, and our presentation is going to be on infrared imaging and technology and its applications. As a reminder, if you are an AIA registered architect, please be certain to sign in with your AIA number, and we will provide you with a certificate of completion for credit. And if you are a lead AP, also note that on our list, and we will also send you a certificate of completion. And for Chapman employees, of course, we will do the registration for you. So with that, I'll introduce our two speakers today. We have Matt Knights from FLIR, who I think will provide a whole wealth of information about infrared technology, and Ben Tucker, Chapman employee who's also a certified thermographer. So no further ado. Matt?
All right. Thank you very much for having me. So this is basically what we're going to run through today. I want to give you a quick background on what infrared is and what, as far as capabilities, it will give you in the world of buildings. So quick introduction. My name is Matthew Knights from FLIR Systems. I always use this picture. It's my wife and I on my wedding day. So what is infrared? I'm not sure how familiar is the group with infrared and what its capabilities are as a whole. Heard of it? Seen maybe some clips on Cops or something like that? Okay. So what infrared is you're basically just taking temperature measurement. All right. So when we look at these images are taken at the same time. And in the night, obviously, we see a little street light. Other than that, it's basically dark, right? Infrared traditionally, or initially, was used for night vision. And the reason that is if you look on the screen here, that's our temperature range. So the white colors are cooler, and the darker colors are warmer. So in this case, it's just being used to see at night, all right? But why that matters in the world of buildings is, if you look around here, that the chimney or around these windows, it's darker areas, so that's heat escaping from a building. All right? So that's how you can use infrared for a building application. We have a ton of different examples. A lot of people will ask what the difference is between, night vision and infrared or thermal imaging. Night vision, the green night vision that you see a lot of times, that just amplifies ambient light. All right, so it takes the moon's light and increases it. Infrared or thermal, it's purely taking temperature measurements. So what that means is if there was zero light, absolutely zero light, you wouldn't be able to see anything visually or with the traditional night vision systems. With infrared, it wouldn't matter because you're just getting temperature measurements. Now, if everything in the world was the same temperature or everything in the environment was exactly the same temperature, then infrared would work, but that never happens. Or infrared wouldn't work in that case. Does that make sense? All right, so now you know a little bit about infrared, so I'll ask guys, Brainteaser. Can anyone guess what this is? What's that?
Mars.
No.
It's your eyeball.
No, that's a very common guess, isn't it? You have one more guess.
A cell?
No. So it's actually a cup of coffee. Just looking down on a cup of coffee. All right, so it's convection, basically. The heat moves around within the coffee, and if you tighten the temperature range up enough, that's what it looks like. Soccer ball, eyeball, and like the moon. Those are the three most common guesses. So now we'll get into sort of the meat of the presentation, building envelope, and where you can use infrared. So some of these are going to be residential, some are going to be commercial, but the concept applies for everything. So the image on the left is your visual image, like you and I would see. Everything looks perfectly normal with this house, right? And then the image on the right is our infrared image. So we see one, a lot of heat escaping through the walls, all right? And then two, there's this bay, for whatever reason, has no insulation. So you see the warmer areas, the lighter colors, in the lighter colors, that's where your heat is escaping. All right, so the whole concept and all of these pictures are going to show what visually you can't see. In infrared you can see. Now one thing to clarify, we're not seeing through the wall. All right, so you can see, you know, support beams and stuff like that. We're not seeing through the roof or through the wall. You're just picking up surface temperature, but the reason it's a different color or a different temperature is heat transfers through, you know, different materials like a wooden stud than it would through an area of insulation. Does it make pretty good sense? So here's another case. Again, visually everything looks perfectly normal. This is just a small issue, but this is from the inside in the winter months, and you can see these two bays, for whatever reason, have missing insulation. You know, maybe something was pulled out to put a new window in, or maybe it was Friday afternoon and they ran out. Who knows? But you can pinpoint, you know, small areas of missing insulation, and this is basically cold air coming through. All right. So another common question I get is, can you do it in the summer months? The answer is yes. You need a difference in temperature from inside to out of at minimum 15 degrees. All right, so if it's 70 degrees outside and windows are open at 70 degrees inside, you won't be able to use infrared. All right, so ideally 15 degrees or above. But in the summer months, this is a case where you can definitely see, we see the insulation has settled, so it would run right along here. All right, and you got warm air coming in or air conditioning leaking out. All right, so it all ties back to energy savings. You can put the best heating system or the best air conditioning system into a building, and if it's not insulated, it's just going out the window. All right, and infrared gives you, you know, a good ability to see where those issues are. Yeah, so it does take surface temperatures of a solid area, but blower door works really well with a infrared camera. And I'll actually show you a couple sample images. But it won't give you like temperature of, you know, the air or the surroundings. You do need a surface. I'll show you in a little bit. There are some images with a blower door. What a blower door does is just enhance the image for infrared, because it's simulating about a 20 mile per hour wind on all sides of a building. All right, so it works really nicely. So this is actually taken, you can see sort of what looks like streaks, right, of cool areas. This is with a blower door hooked up. So you can't see the air flowing, right, but you can see where the air has flown against the surface. All right. So this is residential, obviously like in attic, pretty common area for losing heat in the winter months. So those can get sealed up pretty quickly and pretty easily. The same concept will apply around windows, around doors in a commercial building. So here's another case. This is a summertime shot from the outside, and these windows have some type of a filling in them to keep them insulated. So these two have it, and the one in the middle doesn't. And you know, in infrared, you can see the darker areas a lot cooler, so we got more air conditioning leaking out of the building through that area. So again, it's a more energy efficient setup to have that insulation inside the window. So it'll make pretty good sense so far. Any questions? So here's another pretty common issue with windows is argon insulated windows. The gas leaks out. And once the gas leaks out, you lose the insulation value that you once had. So visually, it's nearly impossible to pick that up. I think it would be until condensation starts coming in. But in infrared, you can see these little areas, so these little circles. That signifies that the argon gas has leaked out and you got cool air coming through. All right, so this is a pretty cool application. You got to be careful when you're imaging windows, sometimes in infrared, because infrared will actually reflect off of a window. So if you get a chance to use a camera afterwards, point it at this window, and you'll actually see your reflection. And what that is, it's your infrared energy being emitted and bouncing off the glass. So glass and shiny metals work similar to a mirror would in the world of infrared. But you can get pretty good relative readings, so this application works. So when we look at the temperature range, so the darker, like your blues and your purples, are cooler. So we got 58 or 55.8 degrees to 72.6. And that's just the range as far as the colors go. Now you can tighten that range or widen it, and it increases and decreases your color contrast. So if you're looking for really small differences in temperature, you can take that range down to 10 degrees or so. And if you're looking for a wider area, you can open it up farther. But the concept of it is similar to color contrast on like an older television. And then as far as the spots on here, when you look at this image, this temperature point right there is 63.5 degrees. Now within the image, we can go in and access almost 77,000 temperature points. All right, so every single pixel along this image has a temperature associated with it. All right, so the way an infrared camera works is it's taking those 77,000 temperature points, sending it out, and then you're assigning a color to it. All right, so it's really just taking temperature, turning it into a picture, and then you're assigning the color. So if we adjust the temperature range on this, we could make that 63 look white, black, blue, purple, any color we want. But at the core, all you're taking is a bunch of temperature readings, putting it into a 2D image. So here's a case where we have a leaking air duct soffit. All right, so if the heating system in a building is working properly, it'll go to the vents and it will come out where it's designed to come out. If there's a leak in it, it's not as efficient as it would be. So we see in this case, we got heat squeezing out right through here. All right, so it's not getting to where it was designed to go, so it's not working as efficiently as it's designed to be. So the emissivity is it's built into the camera, and you can put it in. You can make an adjustment to it. When you're looking at like a wall or 90% of buildings, it's going to be a very high emissivity. So leaving it at between 0.85 and 0.95, you're safe. If you're looking to get exact temperatures, you'll want to have that emissivity setting dead on. From a building standpoint, a lot of times you're looking for relative temperature readings. The one time you have to be really careful is when you're looking at a shiny material, like a glass or a shiny metal. It's really reflective, so your emissivity is 15.15 rather than 0.9. What that means, without going too deep into it, it's the percentage of the reading that is emitted from the object, and the other bit, so in this case 90% of the reading is emitted from the object, 10% is reflected. All right, so ideally in infrared it's 100% emitted, and then you're going to get a exact temperature on that spot. As it goes down, the camera allows you to make adjustments, so you can maintain exact temperatures even if you have a lower emissivity. But for a lot of building work, you won't have to worry about it too much because you're looking for relative differences. So another thing that works great, and I don't have the visual image, it would be nice, but it's just a blank concrete floor here, is finding radiant heat. Radiant heat pipes, radiant heat leaks. So if there's a radiant heat leak, you'll just see a sort of a blob of moisture or water underneath the cement. So in a case like this, you can track where the pipes are. If you're drilling holes or something like that, you can pick them up. For whatever reason, this one tube didn't reach the edge. I don't know if it was by design or, again, they just ran out of products. But it works really well for that, as far as tracking where the radiant floor goes. Another thing, sometimes I hear that we make these buildings so tight that they can't breathe, right? And then you have moisture issues. So we're worrying so much about making an energy efficiency. If it's too tight, it can be a problem. I don't think this is a common issue, but from what I hear, it does happen from time to time. So ensuring proper vent flow. All right, so this is just a bathroom vent, and ensuring that it's getting out, circulating that air. So a couple other applications other than insulation within the building. So other things you can use an infrared camera for, finding moisture issues. All right, so when moisture is evaporating, it's a different temperature than its surrounding. All right, or in this case on a roof, you got a rubber roof, and right here is just spray painted where the moisture is. The way this works is you go up in the evening, all right, after the sun's heated up the entire roof all day long. The area where it's dry is going to cool at a faster rate than the water is, all right? So you're actually looking for a warm blob in the evening. Or sometimes you can do it in the morning right after the sun has come up, and you'll be looking for that cooler area, all right? If you go up there at noon, the water and the rest of the roof has equalized. It's going to be the same temperature. And again, these cameras are just taking temperature measurement, so they wouldn't see it in that case. And then internal, so if you have plumbing leaks, something like that, or water's just running in because you didn't clean your gutters, you can pick that up with infrared as well. So in this case, we see, visually you can't see anything, but in infrared we see those darker areas, and this is where all the moisture has run through as far as all the dark areas there. And this works really well if you're working on, if you want to make sure you're drying the area properly, because to the touch you may not feel that it's still moist, all right? But an infrared camera is so sensitive that if there's any moisture there that's still evaporating, it will pick it up. So you can monitor your drying process pretty well. Another thing, because people are always chasing water leaks, especially in commercial buildings, a lot of times you'll have the water coming in this room, and it's really initiating 50 feet away and running along a roof. All right, so this is a small example of that. This is on someone's 3-season porch, and you can see the water was leaking down right here or right over here, but it's actually initiating here and just sort of running a couple feet and then coming down. So infrared will help you track where the moisture is coming from rather than anyone can see an area that's just leaking. All right, so a couple other things that can be, an infrared camera can be used for safety or for making sure a plant stays up and running. So at a Gillette, they're making razors, and if they get an electrical problem and shut down a line, they can't make razors. And if they can't make razors, they don't make as much money, right? So to monitor electrical equipment, you can look, and when you have a loose connection, so visually these 3 fuses look perfectly normal. When you have a loose connection, it generates a lot of electrical resistance, which generates heat. All right, so you can pick it up in infrared. You see this area, it's over 300 degrees. All right, this is a pretty significant problem. Whereas if it's working properly or after it's fixed, that's what it should look like. Same temperature, same color, okay? Another thing is when you have all this electrical resistance, you're using more energy than you need to be using, all right? So this costs more in energy costs in addition to being a safety hazard. Another application or similar concept would be motor inspections. So you got motors running, and if a motor's overloading or if a motor's running inefficiently against how it's designed, it generates, or it uses more electricity, uses more energy, all right, in addition to the potential of shutting a plant down. So we got a couple cases here. On the left is a electric motor running 200 degrees. It just shouldn't be that hot, right? They need a bigger motor there. And then in this case, we got 2 motors that should be sharing the load, but this one's 70 degrees warmer, all right? So that motor actually failed 2 days after I was there, but it's also causing a lot of extra energy use. Then another big a big problem that a lot of plants have that are running steam is steam traps that leak. A steam trap that leaks can cost anywhere from $2,000 to $5,000 a year for a company. All right, so the way a steam trap should work is you got steam coming in, it's blocked, and then condensate going out, so it should be cooler like in this case. But when it's blown, you got steam coming in and steam going out. All right, so the trap's not working at all. It's just a lot of wasted energy to make that steam. This is a case down below, same thing. We got steam in, steam out, same temperature, whereas these are working properly, steam in, condensate out. So to get to the blower door. So just another tool that works well with infrared. Can be a little tricky in a large commercial building to use a blower door. Residentially it's very easy, but what it does, it enhances the image, makes it a better looking image, and it actually looks where you can see the stripes of cold air. All right, so it shows you a more, I guess, enhanced image or a higher quality looking image when you have a blower door set up. So it's just something that works, another thing that works hand in hand with infrared. So that's it as far as my portion of the presentation. All right, so now Ben's going to give you a run through some commercial case studies or things that you've been working on.
Yeah, just got a handful of slides here that will sort of further elaborate on some of the concepts that Matthew started to show. Some examples that we've run into over the last year or so. Some of these older buildings, a lot of problems in these older structures. This is a series of buildings, an old town hall and fire station that we were engaged to investigate the envelope on. Our infrared images show us a number of different issues here. Some of them are kind of obvious. You can look at an old door like this and open it up and see that there's going to be some issues with the weather stripping, but the infrared image really highlights both the lack of weather stripping as well as the inefficiency of the door. These old raised panel doors, you can see the thickness of the door panel itself versus the tongue of the tongue and groove application will really affect the insulation capabilities of that door. Similarly, this is a large double height space where we didn't have ready access to the attic, but you could see quite clearly that the insulation in this side had a couple areas where it was compromised, both here and up here, which led us to dig in deeper, get up into the attic, and we could see this is the resulting this is the result down here where the insulation had simply just been removed or fallen down. That led us, this infrared image led us to further investigation, which clearly showed the problems. But in the visual image, there was no difference. Similarly, in this issue right here, you can see there's another spot up, it's not working quite so well, up here, another area. We dug around up there and we could see that when sprinklers were added at some point during a renovation, the sprinkler contractors had simply pushed the insulation out of the way and never put it back. Simple issue to fix, but we were able to easily locate it and fix the issue quite quickly. Some other examples of weather stripping. These old double hung windows had tongue and groove type of weather stripping, which over the years had been bent and dented and were no longer operating correctly, no longer sliding into the groove. And so you could, the infrared image enabled us to quickly determine where some of those compromised areas were, where the drafts were coming in. Over on the fire station, there were a number of old doors, which you see up on the top. And you can see, again, some similar to the entry door we saw before, weather stripping issues as well as the poor insulation qualities of the door itself, whereas the new doors had a much more consistent insulation capacity, much tighter. In particular down there at the weather stripping, you can see how tight it is down there at the bottom. A lot of times what you'll see is joints between buildings is where you'll see some heat loss. They were never detailed properly or never sealed properly. This is highlighting where the issues are. Fixing these issues are sometimes the bigger challenge. There's a lot of demolition that would be required to get back in there and seal up that joint correctly. Similarly, interiors, the framing on a corner of a building often is done in a way where there's no room for insulation. It's all packed with 2x or 2x6s, 2x4s, whatever it is in this particular application. But you can see what that results in the insulation capabilities of that particular wall. Pretty good on either side of it, but the corners, you're losing a lot of energy there. Yeah, especially in an older building like this, they weren't caulking anywhere probably, and they packed out both corners so they'd have some places to attach the lath or the plaster to, and as a result, there's no insulation in that cavity, and so you're getting some conductive heat through the framing members at the corners. This is our building out back in the alley. We found a couple areas, unfortunately, after we did our renovation, where we saw some insulation was either missing or had settled. But you look at these walls and you can pretty clearly see the problem areas. This image here shows you pretty clearly what Matt was talking about earlier in terms of the reflected temperatures of this shiny glass right here. You can see the trees and the sky beyond. We're actually measuring the temperatures of the reflections that we're seeing in the window. So that's something you need to be very careful of when you're measuring temperatures of windows and other highly reflective materials. And then I think this is the last one, just another weather stripping issue here around one of our doors, showing how much energy is lost without proper weather stripping. So that is it for us. We do have a couple cameras over here which we'll turn on and let you guys play with and show you how some of them operate. Open the floor up to any questions you might have for Matt or myself or anybody.
Yeah, so the cost of cameras are now, they'll range anywhere from $1,600 up to $35,000. All right, and you get more capability like anything as you move up. Like a $2,000 unit is going to be a lower resolution, a grainier type of image. So what that means is you need a bigger difference in temperature from inside to out for it to be functional. But on a cold winter day in New England, you still find issues. They have their limitations, but yeah, so it depends on what you're looking to accomplish. If you're looking to provide a service where you're going to be giving a report to customers and you want to be able to use it the majority of the year, you'll still need the higher resolution. And those start in the $9,000 range and on up from there.
What was the cheapest camera 5-10 years ago?
Yeah, so 5 years ago, $50,000 was the base, and that was it. And there was no other option, And then a couple years after that, there was a $25,000 camera, and then a $10,000, now a $2,000 camera. So they've continued to come down, and that's a big reason why this industry has accepted infrared so widely. For a building inspector to spend $50,000 to look at, or a home inspector to spend $50,000 was irrational. But for a home inspector to spend $2,000 makes a lot of sense for them then,
The $2,000 camera would be enough for a home inspector to use?
Yeah, again, in good or ideal conditions, it will find issues. Yeah, but those $2,000 cameras, they're typically designed for electrical inspections. But we've got a couple different options. They're ranging from $5,000-$6,000 to $10,000 or so here. So you can sort of see the differences.
This image right here was taken with the lower resolution camera. This is one of the sort of base model cameras. And you can see the graininess of it. It's also got a smaller size. It's just a smaller pixels. It's like buying a cheaper digital camera, lower resolution. These other images here, you can see the clarity and the focus and the detail. This is the higher resolution, more expensive cameras. And these aren't the $35,000 ones that Matthew's talking about, but that's the difference between the $5,000 and the $10,000 cameras. Any other questions?
I got one.
There's a number of different applications or scenarios where we use it. Those buildings we were showing you earlier, the older fire station buildings, we were engaged to just come in and find problems with the envelope. They knew it was an old building and they wanted to highlight the issue. So we were coming in as sort of an audit type of scenario. What we've been doing on a number of other occasions is just when we have a building wide open, which we do as renovation contractors very often, is for our own quality control, we go around and see where there's problems and we button them up. So we use it internally as well as externally. So it's definitely a tool for that process. There's no specific lead criteria associated with infrared analysis. But using infrared to help you confirm that you have installed your air sealing and your insulation properly so that you have achieved the ratings that you're hoping for is very beneficial. Because you can specify a certain insulation and a certain air sealing, but it's all in the details of the installation itself. And if you, what a lot of insulation contractors will do nowadays is they will use blower doors in combination with an infrared during the installation process. So if they see an issue, everybody's on site right there and they can button it up and know that at the end of the day it's a quality control issue, that they've done it as specified.
Another application that we've been engaged to use this on is, as Matt had pointed out on the roof, was for moisture detection. So ground level of a building gets flooded after torrential rains. There's moisture intrusion or just flooding on the first floor, and now we're tasked with finding the source of that leak. And in some cases it's a flashing issue where there's a deficiency in the flashing or in the waterproofing along the foundation. And then that it allows us to find the extent of the moisture as well, so that we don't have to go in and demo the entire space to re-drywall all of the space. We can find the extent of the damage and limit the scope of the work in that way, and also pinpoint the source of the leak so that we can address that at the same time.
Last spring we did a lot of that with all the flooding, and there were a lot of ground floor commercial applications that got some water in them, and a number of our building owner clients engaged us to get rid of the drywall that got wet. But without knowing exactly how far up the moisture had wicked in the surface, they were, for their tenant negotiations, were saying, let's take the worst case scenario, cutting it up to 5-6 feet, something like that. We were able to go in with the infrared camera and draw a definitive line as to where the moisture had stopped and only cut out that much drywall. So. Yeah, that's certainly one of the tools you can use. We haven't used it for that specific application yet, but after the ducts are sealed, but before you insulate them, you could certainly turn on the system, do a scan of the ducts themselves, see if you've got any air leakage out of the joints, fix all those issues before you wrap them in insulation and hang the ceiling and cover it all up.
I think also in terms of response from clients, if we try to proactively, we did one project where we replaced an extensive number of windows and all of the PTAC units that were below all of the windows. So just to be proactive in our approach, we shot all of the rooms as we went along, and we found insufficient insulation and caulking issues, just deficiencies in simple caulking that we were able to address as we went on with the caulker in process, saving tremendous amounts of money. And then the response from the client was overwhelmingly positive. They couldn't believe that we would take this action, and this is great, and it assured them that also for us that now we have a log of how tight the work actually is. So in one sense you could say, well, it potentially prevents some later liability issues, but in another sense it's fantastic for the client to know that the work was done in a tight, efficient fashion, and it's increasing the building's efficiency. It's totally different. One is, it's one's checking for material difference. So when you do a pro scan on a floor, you're looking for metal embedded in a slab, say for example, so you don't cut through a conduit in a slab. And I'm not exactly certain, that's radar. And so it's going to reflect off the different materials differently and whatever the material's made of. And I think that's more of a safety concern before you cut or enter something, as opposed to looking for potential leak issues. For example, if you were to shoot a roof, I think you'd already know that your roof is leaking.
Yeah, so you can do anything that you could do on the camera in the software. So like you can, in this case we have 2 temperature points. You can adjust your temperature range to increase color contrast. You can zoom in and pan around the image. You can adjust your color palette. You can actually go in and get temperature points, so it's fully post-processable. The term that is used is it's radiometric, or the temperatures are embedded. So all the images are.
You got to get your focus right in the field, and you got to get your range, your temperature range, your overall temperature range, and obviously your distance, how far away you want to be from the image, subject. But everything else you can adjust. And this is an example. Typically you'll see the image that comes out of the camera is a spot right in the center of the image. We can go into the software, blow that away, and highlight, a hot spot and a cold spot, and see the differential between those two. Yeah.
Yeah, you don't need a tripod. So it's updating its temperature readings 30 times a second. So
You don't have long open apertures like you would with it in film.
Okay, so it's
It's just a snap, just like
no aperture, so there's no focal points or anything like that.
no.
So do you have to be in a static position when you hold this? Or, I'm getting back to this mechanical thing. Or could you do just simply a walkthrough, and as you're walking through, noticing the differences so that you can tell somebody,
Yeah.
let's check this or
You
this?
certainly can, and they're actually some of the more involved cameras will record video, so you can see that. But if you're just doing it as on a visual basis and you don't want to record it, you can just, it's live just like a digital camera. Whatever you're pointing at is what you're showing at that one particular time.